Oh, you did not try this one.
I tried it, but I didn't get how to do it.
Okay, okay, yeah. So the idea is that the net electric field inside that plate would be zero. That is the idea, right?
Yes,
Right?
sir.
That was the idea. So we did with two plates, and then the last one was this. So let's, yeah, then let's do this question. So, okay, so let me erase this thing, and let us do this from the beginning. Right. So at this point, we know that E net is zero. That is the idea that we have, right? That is the idea, right?
Yes, sir.
So let's say that X charge is accumulated at this point, right? Then what would be the charge at this point, at this side? Let's say that plus X charge is accumulated at this side. So what would be the charge in this side?
E net minus X.
No, so we are talking about the charge, right? What is the total charge on that? On that plate, what is the total charge? Oh, so, oh, Sufyan, you're also here. Good. Okay, so yeah, so the total charge is Q. So the charge in the left hand side, okay, yeah, we are doing this because we only did the Sufyan with you, we only did the vectors portion. So now, because you are in this class, right? So we are doing this difference between the plate and a sheet, right? So we have this plate, and the plate will have two sides, the left side and the right hand, right? So there would be different kinds of distribution on this plate. But the key idea of the plate is that the net electric field that has to be zero. So that is the thing that we are calculating. And before we do this thing, we need to remember that, let's say if we have this sheet, then due to this sheet, the electric field due to this sheet would be sigma by 2 epsilon. That is the electric field in this side as well as in this side, right? So if it is positive, then this would be outgoing. If it is negative, then this would be incoming. So that is the idea, and then we have to find out E net that has to be zero. Okay, so now let us get back to this problem that if this is X, this side would be how much? What would be the charge in? Rishita, we have already done this type of thing before, right? With these kind of questions. So we have already done all of these questions. So tell me what would be the charge in this side? Total charge is Q. You take X charge in this side. So what is remaining in this side? Simple algebra. Q minus X. Right? That would be the charge would be there in this side. Right? Clear, everyone? Is it clear, everyone?
Yes, sir.
Yeah. So now we have one charge which is X, and then other distribution which is Q minus X. And that is there in this plate. So this is a whole area. Right. And there are other contributions from 4Q and 3Q. So now, what is the electric field contribution at this point? So at this point, due to X charge, the electric field would be in which direction? Right or left? What would be the direction? direction of the electric field at this point due to X charge? Right or left? This is positive, so electric field should be outgoing. So that would be in this direction. Right? Is it clear, guys? Is it clear, everyone?
Yes, sir.
And what would be the electric field due to this Q minus X charge? What would be electric field? Right or left? Again, this is positive, so that thing would be outgoing. So this is due to EQ minus X. Now there are other charges as well. So 4Q, this is positive. So this would be in this direction. And this is 3Q, so again this would be in this direction. So we have 3 electric field in this direction and 1 electric field in this direction. And E net is 0, which means that they have to balance each other. So E net is 0, which means that E left would be equal to E right. Right? Is it clear, everyone? So E left is E4Q plus EX plus E3Q. And E right is EQ minus X. So what would be the electric field due to this 4Q? That is sigma by 2 epsilon, right? So this would be sigma of 4Q divided by 2 epsilon. This EX would be sigma X by 2 epsilon. This thing would be sigma 3Q divided by 2 epsilon naught. And then this would be sigma Q minus X divided by 2 epsilon. So all of these would cancel. And what is this surface charge distribution? What is the sigma? What is sigma in terms of charge?
Q by
Q by U, right? So this is Q by U. So for all of these different kinds of distribution, we see that all of these have same areas, right? So this would be 4Q by A. This would be X by A. This would be 3Q by A. And this is Q minus X by A. So again, area will cancel. And we have 7Q plus X. And then this is Q minus X. So this goes in the left-hand side. This goes in the right-hand side. So 2X is Q minus 7Q. So then what would be this thing? So this is 2X. This is minus 6Q. So X is minus 3Q. Right. Which means that this side will have a charge of minus 3Q. So this side will have the charge of, let me use this. So this is minus 3Q, which means that this charge would be how much? Left-hand side. That would be how much, guys? With the charge on the left-hand side. Yeah, what would be the charge in the left-hand side? So it is already
4Q.
4Q, right? So Sufyan is saying 4Q. What about you, Rishita? What do you think? What would be the answer? Yes, what would be the answer? You see, that is Q minus X. X you have already got. So Q minus of X which is Q minus of minus 3Q, which is Q plus 3Q, so that is 4. So yes, Sufyan, you are correct. So this would be 4Q plus, now because these are the regions between the plates, and between the plates, electric field is 0. So whatever this charge is, so this charge would be opposite to that. So this would be plus 3Q. Plus 3Q is in this side, right? So this would not be positive. So this is a negative charge, right? So if we correct this thing, so this would be negative. So this side is plus, right? Which means that this side will have how much charge? How much charge will have this side? Oh, Sufyan and Gishta, what would be the charge in this side? Total charge is already at the top. So what would be? Yeah, what would be the charge in the right hand side? The total is 4Q, 3Q we have taken, so this would be Q,
Okay.
right? This is Q. Now this is Q, so this side will also have opposite to that. Right, this would be minus Q. So you have taken minus Q from this thing, so this would be how much?
Okay.
4, right? So this would be, so this would be the final distribution of the charges, right? So if I write the final distribution, so although it was earlier Q, 4Q and 3Q, but final distribution would be 4Q. This is plus plus Q. This side is what? Minus or plus? So this side is minus 3Q. This side is plus of 3Q. And this side is what? Plus of Q. And then the other plate. So this side will have minus Q. And this side will have plus 4. Right, so that is the final distribution. Initial distribution was what? Initial distribution was this thing. So initially it was Q plus 4Q and 3Q. But the charges would be redistributed due to the electric field, and then it would be redistributed like this. So initial case was this thing. So this is the question. And the final distribution we have just calculated. So key idea, always remember that key idea is that E net is 0 at the center, right? Inside that plate, E net is 0. So that is the key idea, right? And you solve this thing, you will get the distribution of the charge. So please note it down. If you guys have any question, please let me know. Please note this one down. And yeah, whenever you guys want me to scroll down the screen, please tell. So this was the question. And I wrote so many things in here. Let me just remove this thing just for clarity, because there are so many things which I wrote. So just remove this. Right. And then we have that final distribution. So I assume that this is positive, but when we solve that thing, we got that this is negative. So please note it down, and then we'll do one more question about this thing. And then we can do the next problem. Yeah, whenever you guys want me to scroll down, please tell me. Yes, whenever you guys have noted, we want you to scroll down the screen, please tell me. Yes, guys, whenever you want me to scroll down the screen, please tell me.
Scroll.
Whenever you guys have noted, please tell me. Done. What about you, Rishita? Noted.
Yes, sir. I'm done.
Done. Okay, good. So now let me give you guys one question, and you guys please try to solve it. So again, the same problem, and the distribution goes like this. So you have, we can increase the number of plates to 5 or many times, right? But let's take 3 plates. This is 3Q. This is minus 4Q, and this is Q. So this is the initial distribution, right? Now, please find final distribution. Idea you guys already. So please please solve it and find the final distribution. Yeah, please solve it, and whenever you get the answer, please tell.
Okay. X equal to 3Q.
Yeah, so you got, what was this distribution? In this side,
I
what
want
is
X,
the X equal to, you got 3Q. 3Q. So the same charge is in here. There is zero charge in this side.
yeah.
How is this possible? So there has to be some.
Yes.
And yeah, Rishita, what did you get?
So I'm still doing it.
Yeah, please. Yeah, so Sufyan, what you try to reach, so you are getting 3Q in this side, which means that there is zero charge. How this is possible? See. And then if this is 3Q, then this would be minus 3Q. So minus 3Q we have taken, so this would be how much? Minus 4Q is, let's say, Y minus 3Q. So this is minus 4Q and plus 3Q. So minus Q this side, right? And then if this is minus Q, then this side is Q. And then this side is 0. Okay, this is what you are getting. And this would be the final distribution if you have X equals to 3Q, right, Sufyan?
Yes.
Okay, so let's see what Rishita is getting. And we can let's do this. Let's do this question simultaneously. So let's take this point, right, and count the contribution of the electric field. So let's say this is X. So electric field would be this side. This is 3Q minus X. So electric field is in this, right? Now, due to this one, the electric field would be towards or away?
Over towards 4Q.
Towards minus 4Q, right? So this would be 4th. Right, whenever we have taken the direction, we don't write the sign. That is the idea. Right, so whenever we have taken the direction, we don't write the sign of these charges. And then this would be repulsive, so this is on this charge. Right, so E left, that is equal to E right. So we have, this is sigma X by 2 epsilon naught, then sigma Q by 2 epsilon naught, sigma 3Q minus X by 2 epsilon naught, sigma 4Q by 2 epsilon. So all these cancels out. And this one again, this would be X by A. This is Q by A. This is 3Q minus X by A. This is 4Q by A. So all of these things cancels out. And what do we have? So this is 2X. And then this is 437 minus 7 minus Q. That is 6Q. So X is 3Q. Yeah, you are absolutely right. Yes, so this would be the distribution. So yes, Rishita, did you get this thing?
Yes, sir.
Yes, good. Both of you guys, very good. Yeah, so this would be the final distribution. And if I can add other plates as well, so you guys can calculate all those things. So that is the idea, or that is the difference between the plates, conducting plates and sheets, right? So they can have different distribution in both the sides. Okay, now the next topic is, because we are doing the application of Gauss law. So the next topic is the solid and non-conducting state. right? Because solid conducting sphere, that thing you guys have already done, right? In your CBSE portion, you guys have already done this solid non-conducting sphere, right? Right, guys? So let's say if I talk about solid and conducting sphere. So this is equivalent to what? This is equivalent to hollow sphere, or I can write conducting sphere. Or I can also write hollow non-conducting sphere. So all of these things are similar, right? All of these things are similar, and what do we have? So we have this kind of distribution, right? This is so this is the example of a conducting sphere, a hollow conducting, or hollow non-conducting sphere, right? So how many regions that we have? Because this thing you have already done, so I will take the analogy in this one. So how many regions do we have in this example? Yes, in this one.
One.
How many? We have,
Okay.
let's say if you have a ball, right, charge ball, so there would be three regions. One would be inside, then there would be surface, and then there would be outside, right?
Yes.
So this is inside, this is surface, and this point is outside, right? So if I calculate the electric field applying the Gauss law, this you have already done. So E inside is 0. Then E surface, this is KQ by R square, right? And then E outside, this is surface. And then E outside is KQ by R square, right? So these are the three variations of the electric field. So if I plot, because this thing you guys have already done, so I will not, I will not do this thing separately. So I will just give you the final result, right? We will not derive this. So let's say that this region, this is the region which divides the surface. This is the variation of R, right? This is the electric field. Now this region is what region? What is this region? Outside, inside? What is this region? Yes, what is this region? What is this region? Let's say this is inside, right? So this is inside, and this is inside. So inside there is no electric field. This is 0, right? At surface, the electric field, this point is R equal to R, right? This is the surface. At this point, electric field is maximum or minimum? Yes, minimum.
So which point?
At the surface. At the surface.
Oh, that's all.
Maximum.
Maximum, right? So at this point, electric field is KQ by R, right? Because it is going inversely proportional. So if we have a closer distance, electric field will be maximum. If we go far, electric field will decrease. So it is going as 1 over R. So this will decrease, right? And it will meet at infinity. So this is proportional to 1 over R square, right? And this point is 0. So this is the variation of the electric field for a solid conducting sphere. Conducting will have all the charges at this field, this is equal to hollow conducting sphere or hollow non-conducting sphere. So that is the variation that you have already done, right, guys?
Yes, sir.
Yeah. So similarly, we will have this solid non-conducting sphere. And what we are going to apply? We are going to apply the Gauss law. So let's apply the Gauss law for two regions, right? So we have this solid conducting sphere, right? And let's say that this has, yeah, so let's say that this has a radius r. And because this is non-conducting, so the charges are inside also. They are at the surface. So everywhere there you have a charge. Right. Now I will also have three regions, but let's divide it into two regions. So one would be this inside region, and the other is this point, let's say some point outside. Right. So let's solve it for inside case. For inside case, I will take a Gaussian sphere. Right. This is this thing, right? The whole distribution. And I take a Gaussian surface. Let's say I want to calculate the electric field at this point, so I take a Gaussian surface. Right. Gaussian surface has this distance r, and this distance is capital. Right. So now, because we are doing what kind of distribution? What kind of distribution is this? This is a solid sphere. So what kind of distribution we will have? The
Surface
distribution.
charge.
Surface charge. So do we have only surface? This is a solid
Volume.
volume charge. So we have a volume charge distribution. This one will have what kind of distribution? This one? Yes.
So
Surface charge distribution, right? So this one will have surface charge distribution. Right. And we are only considering, so the charge distribution we are considering uniform. Right. So what will remain same? What will remain same? Yes, what will remain same? If I'm talking about uniform charge distribution. If I have a homogeneous water, right? Water is homogeneous solution. So what remains the same?
Charge.
Charge?
the constitute.
Constituents, yeah. So if I have one bucket of water, if I have 1 cup of water, so what will remain the same? See that volume is changing, and yeah, if there are charges, so charges will also be different, right? What is a neutral thing? But let's say that we only count the electrons. We will have equal number of protons as well, but let's say we are only counting the electrons. So the electrons will be different, right? Charges would be different. What will remain the same in the bucket of water? Let's say if I am talking about mass. So mass of 1 cup of water and mass of one bucket of water. They would be different, right?
Yes, sir.
Yes, sir.
Volume would also be different,
Yes.
right? But because that is a homogeneous solution, so its density, right? Its density will always remain the same. Is it clear? So I'm talking about the mass density, right? Mass density of water will always remain the same. Similarly, we are talking about uniform distribution. So what will remain the same
Charge
in here?
density.
Charge density will remain the same. Absolutely correct. Right. So is this point clear to both of you guys?
Yes, sir.
Right. Good.
Yes, sir.
Yeah. So now we know that what is the Gauss, right? What is the Gauss law? Applying the Gauss law. So what does Gauss law say is that this is E dot ds. This is Q enclosed by epsilon, right? And now we are talking about this Gaussian surface. We're talking about this Gaussian surface. So because the electric fields are going radially, and we are also taking the surface area radial. So both of them have same direction. So this will become simply EDS, and this is the surface integral. This is Q enclosed by epsilon, right? Now electric field is uniform, so I can take it outside. So this is only the total surface area. So what would be the total surface area? What would be the total surface enclosed of this sphere? What would be the area of that sphere? The Gaussian sphere. Yes, guys, what would be the area of the Gaussian sphere? Yeah, if you have a sphere, so what is the area of the sphere? You guys have, yes?
R square.
4 pi r
4 pi.
square, right? 4 pi r square, right? Absolutely correct. So why you guys are hesitant? So this would be 4 pi r square. This thing we have solved. But Q enclosed, let's say that total charge is Q. But Q enclosed inside this thing, that would be different. Right? That would be different, but we have one thing, which we are very confident in, which we know already. And what is that thing that we know? That the charge density is same. That is the key point. Right? So for this thing, what is the charge density? That would be, let's say, rho. And for this thing, that would be rho prime. Right? Both are equal. Is it clear, guys?
Yes, sir.
So this density would be Q by volume, right? And this density would be Q, which is the Q enclosed, right? That by volume prime. Clear, everyone? Is it clear?
Yes.
Yes, sir.
So this is Q, and what is the volume of the sphere? What is the volume? And we are talking about the whole sphere. In this one, we are talking about the whole sphere. So what is the volume? Volume of the sphere, that is
4 pi. 4 pi. R
4
square.
by 3 pi r pi cube.
by 3 pi r cube. Which are small or capital?
Capital.
Capital. Yes, Sufyan, are you agreeing to this thing?
Yes, sir.
Yeah. And in this one, again, the volume is, again, we are talking about the sphere. So this is, right. So
Yes,
4
sir.
by 3, 4 by 3, this one cancels. And the Q is, which is the Q enclosed? That is Q, R cube divided by this R. Right? Is it clear, everyone? So we put this value in here. This is Q R Q divided by R Q and epsilon. So we take this thing in here, electric field, this is inside. This is Q by 4 pi epsilon 1. Right? And, oh, this is a smaller one. So this is a smaller one, and then R square, and then R. So this one will cancel. And E inside would be how much? That would be 1 by 4 pi epsilon mod Q by R cube and R. So what is the variation? What is the variable that we have? What is the variable in the right hand side? What is the
Charge.
variable? Charge is fixed, right? The total charge is fixed. This capital R is also fixed. This thing is variable. So what we can do is that we can calculate the electric field at this point. We can calculate the electric field at this point. We can calculate the electric field at this point, this point, this point, this point, this point. So all these things. So this R is changing, right? This R is changing. So this R is a variable, but this one will always be fixed, right? So this is fixed, this epsilon naught is fixed. So E is varying like R. And what is the geometrical meaning of this thing? What is this graph? What is this graph? Y proportional to X. What is this graph? Let me write it clearly. Y equals to mx. What is this graph?
It's a slope.
Slope is this thing, M. M is slope. Yeah, you are nearly there. But what is this graph?
It's the equation of a straight line.
Straight line. So this graph is a straight line, right? So this is a straight line. Okay, good. So inside the sphere, the graph will be a straight line. And let us calculate the outside region. We can calculate at the surface using this idea. We can calculate at the surface. So at surface, what happens with R? This R will become what? This small r will become what?
Capital R?
Capital, right? So that is the surface. That is how you identify the surface, right? This is how we identify the surface. So we just put this value, then E surface would be how much? This would be Q R. Yeah.
4 pi epsilon naught. R square.
So this will cancel and we will get what we got out. So this would be KQ by R, right? Okay, please note down this thing and then we'll talk about the outside. Because why we are doing this problem? Because in JEE syllabus, you have those cavities problem, right? So you will be given some solid sphere and then they will give you this cavity. And then they will tell you to find out the electric field of this cavity. So yeah, we have to do, to understand these questions, we have to understand this solid sphere first. Okay, yeah, please note down this thing. And whenever you guys want me to scroll down, tell me. We have only calculated one region, right? We have only calculated inside. Outside, we have to calculate. That we'll see in a moment. But that would be very easy, right? So yeah, but before we do that, please note this one. Whenever you guys want me to Uh, Scroll down the screen, please tell.
Okay.
This thing you have always done, right?
Okay.
Yeah, whenever you guys want to scroll down, please.
Future.
Yes. got disconnected.
So done.
Done. Sufyan, you have noted it now.
Yes, sir.
What about you, Rishita? Noted.
Yes, sir.
Good. So now, who was okay? Learnivio. So the next part was the outside. This would be very simple because we have this distribution, right? And let's say we want to find out the electric field at this point, whatever point. So we will make a Gaussian sphere. We'll make a Gaussian sphere. Right. And let's say this distance is, this one is the variable. Because we can calculate the electric field at this point, at this point, at this point. So this R is the variable one. This one is always fixed. Right. So if I use again the Gauss law, again the same funda, and this charge is Q, right? This charge is Q. So this would be very simple because this left hand side we have already solved.